Okay. Yes. My name is Mr. Rene Costa, a PhD student from Nelson Mandela African Institution of Science and Technology, Arusha, Tanzania, studying under the Department of Material and Energy Science and Engineering, and working as an assistant lecturer at the Open University of Tanzania. Today workshop is titled Methanidine Isomerization and Decarboxylation, Thermodynamic and Charge Transfer Dye Properties towards DSC application. This presentation deal with the electronic structure workshop conducted through University of California, Merced, and a visual poster session. This workshop it covers the instability of a well-known drawback of the dye, which impairs the usage of the DSC application. This project covers structural, thermodynamic, and electronic properties of the methanidine dyes through the DFT and 3DFT computations. The study was based on the thermodynamic approach, where the two isomeric structures were investigated, which shows the decarboxylation and the detached carbon dioxide. So it is observed that it is worth to study these optoelectric properties due to its useful applicability in dye-sensitized solar cell application. The study investigated the vibrational spectra of these molecules together with the geometrical structure, where the two isomeric structure observed to undergo the decarboxylation reactions, and the two isomeric structures and its decarboxylated product were investigated in terms of their thermodynamic parameters and its optoelectric properties, whether they are useful in the applicability of the DSC application. The thermodynamic properties which were investigated cover in a range of the enthalpy of reactions at zero and at ambient temperature, together with the Gibbs free energy and the entropy. From the analysis, we observed the reaction 1, reaction 2, and reaction 3. The reaction 1 deal with the isomerization reactions of these two isomeric structure of bent structure and the planar structure of the methanidine. And the second reactions and the third one cover the decarboxylation reactions, where these decarboxylation reactions, these reactions show that on this planar structure, the enthalpy of the reactions were observed to be negative values, of which the isomerization reaction and the bent structure, its decarboxylation, so shows the enthalpy to 0 and ambient were positive values. The Gibbs free energy of all among these reactions were spontaneous, and the entropy of all these reactions observed to be positive. It means there is the reactions, the molecules are not rigid. It means the positive values of this entropy. However, the thermodynamic characteristics of the isomerization reactions were observed to be, as the temperature increases, the Gibbs free energy shows to increase its spontaneity for these isomerization reactions. And the entropy and enthalpy were positive values for this isomerization reaction. However, the pressure ratio for this bent and the planar were investigated as the temperature of this pressure ratio toward the planar, this bent one. Also, the Gibbs free energy of decarboxylation reactions, reaction 2 and reaction 3. As the temperature increases, also it is observed that the spontaneity were increasing.
Rene.
Yes.
Can I interrupt you? It looks very nice, but I need to go soon because of all these other good posters. Could you give me the basic summary at the, kind of the bottom line of, what you're doing?
Yes. Yes, Professor. Your question, you say about which reaction here?
Yes, right. Because I have to go soon, like, what would be the conclusions from your slides today?
Okay.
From your poster, yeah.
Yes, the conclusion is say that the bent structure here will show that this bent structure, as we can see from this structure, the bent structure, it has this hydrogen bonding, but the planar, it lack the hydrogen bonding here. But both of them, they show the decarboxylation reaction. So in my conclusion, I said that the bent structure is more stable energetically due to these hydrogen bond formations. But both these conformers demonstrate instability by undergoing the spontaneity decomposition. But these dyes, both of these isomers, they show the suitable generations. But this decarboxylated one, it failed to generate because of the generation because of the HOMO is above the potential of this electrolyte, Professor.
Okay, nice. And what's the method that determines the hydrogen bonding? Is it a straight chemistry calculation with electrons, or is it a kind of a phenomenological model for the hydrogen bonding?
Okay, this hydrogen bonding, these molecules which show hydrogen bonding, we took it from the chem spider, but the one which as planar, we tried to draw this structure through Avogadro. So during computations, we observed that this which show hydrogen bonding from chem spider, it show the hydrogen bonding compared to the one which is drawn from the Avogadro.
Okay.
Yes.
Okay, thank you very much, and best wishes in your work.
Yes. Okay. So the charge transfer properties were also investigated, but it showed that this planar, although we are more stable, but it fails to its cation, the optimizations show the decarboxylation. That's why we didn't show here the regulation energy of the whole because of failure to have the stable structure of the planar during the optimizations of the cation. That's why you consider that the bent structure for the charge transfer properties show better performance because no any decarboxylation were observed for the bent rather than this planar. And the decarboxylated molecule shows both properties were okay and goes smoothly. And the frontal molecular orbitals of the considered dyes and the vacuums were also investigated, and the movement of electrons in HOMO and LUMO were analyzed. Yeah, the UVB spectra of the dyes for among the structures were investigated and estimated for vacuum. And the energy of the molecular orbitals were investigated, and the very interesting parameters were also investigated. And according to the conclusions already explained due to Professor asked on that part. So thank you for your listening, and I welcome you for the next days of our workshop presentations. Thank you.